Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about PROFIBUS. Stands for Process Field Bus, and it is an open field digital network or field bus standard, which is responsible of communication between field sensors and the control system or controllers. It is suitable for both fast and sensitive applications and complex communication tasks. The instrument tag, units, description, alarms, diagnostics, etc., they are supplied in files in DDL language, device description language. Something to note is that PROFIBUS is constantly evolving to be able to cover more and more needs thanks to the development of new features. PROFIBUS networks use 3 layers of the OSI model, a topic of which I already have a video that I will leave you right here. Layer 1, which is the physical layer, complies with these standards and enables the equipment to be powered by the same pair of wires. PROFIBUS can have 3 types of physical communication media. The RS485, which I explained more fully in my communication video that I will also leave you here. Fiber optic transmission, Manchester coding, and bus powered or MVP, which is an enhanced safety system that is available in potentially explosive environments. Layer 2, which is the data link, uses FDL system, which combines the master-slave methodology with that of token pass. In the master-slave ones, the master sends a request to the slave so that they, in turn, send the information requested. The master are generally controllers, and the slaves are sensors and actuators. The token or token passing method ensures that not all participants send data to the network at the same time, and only the devices that have the token at the time can send data packets to the network. Layer 7, which is the user layer, standardizes the basic functions of all instruments so that the devices from different manufacturers are interchangeable. That is, if we change a flow meter for another from another manufacturer, the reading will be the same. PROFIBUS uses the bus topology, which consists of a central line in which all devices are connected, which eliminates the need for a line from the controller to each of the devices. Before, each of the PROFIBUS devices had to be connected to the central bus, and now it is possible to apply a new two-wire system, which is a topology in which the central bus, PROFIBUS, can be connected to a PROFINET Ethernet system, to be able to connect several PROFIBUS buses to each other. It is very common to think that PROFIBUS and PROFINET are the same or that one is a variant of the other. However, the reality is that they differ by the technology that each one uses to communicate, since PROFIBUS is considered as industrial field bus network and PROFINET is a network based on Ethernet. PROFIBUS has 3 user profiles: PROFIBUS FMS, DP, and PA. PROFIBUS FMS, or Field Message Specification, was the initial version of PROFIBUS and was designed to communicate programmable controllers and PCs. However, it is being deprecated because it is not as flexible and is not suitable for complex messages or communications in a larger and more complicated network. PROFIBUS DP, or Decentralized Peripherals, is the most universal, simple, fast, and used. It is currently used in most application profiles, which are those that allow the user to combine the requirements for a specific solution. Those in the screen, for example. PROFIBUS DP has 3 versions: the DPV0, DPV1, and DPV2. The DPV0 provides basic functionalities, including cyclical data, transfer, station, module and channel diagnosis, and interrupt support. The DPV1 adds communication acyclic data oriented to transfer of parameters, operation, and visualization. And the DPV2 allows communication between slaves, and it is oriented to drive technology, allowing high speed for synchronization between access in complex applications. PROFIBUS PA, or Process Automation, allows automatic process even in areas with risk of explosion, has a speed of 31.25 kilobits per second, uses this standard that provides power to the same communication bus and intrinsic safety, which is basically to prevent the sparks from being generated by limiting the current, voltage, power, and temperature. Use the streaming method MVP. It has a response time less than 60 milliseconds. It is applied in the field and has external device control, which means outside the cabinet. So, this will be all for today's video. Don't forget to give me a like and subscribe. I love videos every Wednesday in Spanish and Friday in English. Adios! Diagnosis, etc. Before each of the devices. Ya.